The question says that explain why a horse cannot pull a cart and run in an empty space. So, for a horse to propel the cart, let's assume that this is the horse and this is the cart that is being pulled by the horse. So, at first, let us assume that there is a ground, it is not an empty space. So, what happens is that horse pushes the ground maybe in this direction, and that leads to a reaction that makes the horse go in opposite direction and thereby pulling the cart. Now if the third agent is not there, then there is no any reaction upon the hopping of horse feet, so there is going to be no motion at all. It explains. Now in second question we have explain why passengers are thrown forward from their seat when a speeding bus suddenly stops. So here the case is that when a bus is moving with a constant speed, let us assume that it is moving at a speed v and it is suddenly stopped. What happened is that the momentum of bus suddenly reached to zero, that is from v its speed reached to zero. Now what was happening initially was that let us assume that this is a person who is sitting on the seat. Now the lower part of the person is on the seat and it is kind of with a solid connection, or due to weight it is fixed, kind of fixed, not fixed but kind of fixed. So when bus suddenly stopped, the lower part of the body stopped, but the head part maybe it was not as rigidly connected as the lower part of his body. That's why due to inertia it continued its motion and thereby it is pushed in the forward direction. Now in the third question we have, it is easier to pull a lawn mower than to push it. So for this we have to make a free body diagram. So let us consider that this is a lawn mower. Now for the resistance in either push or pull, or for resistance in its movement, there is a role of friction force. Now friction force is defined as coefficient of friction mu and its weight, the body's weight. So friction force, the magnitude of friction force can be given by mu and w, the product of mu and weight. Now friction force is always acting against the motion. So let us assume that the lawnmower is first pulled. So this is the force that is pulling the lawnmower. Now what happened is that weight is acting in the downward direction. Force has a component which will act in the upward direction, the pulling force, and also in the horizontal direction, which will lead to the pulling of the lawnmower. Now the upward component of the pulling force will be responsible in reducing the overall weight. So the frictional force will be reduced because overall weight will reduce and thus frictional force will reduce. That's why it is easier as compared to the case of pushing. So let us now consider the case of pushing. So let us assume that force is acting in this direction. Now when we take the component, then it is assisting the weight, or one of the component is in the direction of weight of the object. So this will lead to adding the weight to the lawnmower, thus the frictional force will increase. Therefore more friction will be encountered when pushing the lawnmower. Now in fourth question we have, a cricketer moves his hand backward while holding a catch. Explain why. Now we know that impulse is given by change in momentum, final momentum minus initial momentum. Now here final momentum is going to be 0 and initial momentum will have some value, and thus force is given by change in momentum divided by delta t. Now when the cricketer pulls its hand backward, then it is increasing time for stopping the ball. Now when the ball is being stopped, the momentum is boiled down to 0, or the delta p has more time to come to 0. Thereby if delta t is increased, force is decreased. If delta t increases, force decreases. Thus the effort to catch the ball reduces when the cricketer pulls its hand backward, because delta t has increased and therefore the ball is being catched easily. Thank you.